Good morning, students. I am Professor Nitesh Sharma. Students, today I am teaching you food preservation. Students, this topic, food preservation, is included in the paper second, Genetics and Biotechnology of BSc Part 2nd. Students, food preservation is very important to resolve the problem of scarcity of food. So, food preservation includes food processing practices which prevent the growth of microorganisms such as yeasts or other microorganisms. Although some methods work by introducing benign bacteria or fungi to the food and slow the oxidation of fats that cause rancidity. Food preservation may also include processes that inhibit visual deterioration, such as the enzymatic browning reaction in apples after they are cut during food preparation. By preserving food, human communities are able to increase their food security through food storage and reduce food wastage, thus increasing the resilience of local food system and reducing their environmental impact of food production. So students, many processes designed to preserve food involve more than one food preservation method. Preserving fruit by turning it into jam, for example, involves boiling to reduce the fruit's moisture content and to kill bacteria, etc. Sugaring to prevent their regrowth, and sealing within an airtight jar to prevent recontamination. Different food preservation methods have different impacts on the quality of the food and food systems. Some traditional methods of preserving food have been shown to have a lower energy input and carbon footprint compared to modern methods. Some methods of food preservation are known to create carcinogens. In 2015, the International Agency for Research on Cancer of the World Health Organization classified processed meat, that is meat that has undergone salting, curing, fermenting, and smoking, as carcinogenic to humans. Students, now we are going to study the traditional techniques of food preservations. New techniques of food preservation became available to the home chef from the dawn of agriculture until the Industrial Revolution. Curing, the earliest form of curing was dehydration or drying, used as early as 12,000 BC. Smoking and salting techniques, improving on the drying process and add antimicrobial agents that aid in preservation. Smoke deposits a number of pyrolysis products onto the food, including the phenols, syringol, guaiacol, and catechol. Salt accelerates the drying process using osmosis and also inhibits the growth of several common strains of bacteria. More recently, nitrites have been used to cure meat, contributing a characteristic pink color. So, students, second process is cooling. Cooling preserves food by slowing down the growth and reproduction of microorganisms and the action of enzymes that causes the food to rot. The introduction of commercial and domestic refrigerators drastically improved the diets of many in the Western world by allowing foods such as fresh fruit, salads, and dairy products to be stored safely for longer periods, particularly during warm weather. Before the era of mechanical refrigeration, cooling for food storage occurred in the forms of root cellars and ice boxes. Rural people often did their own ice cutting, whereas town and city dwellers often relied on the ice trade. Today, root cellaring remains popular among people who value various goals, including local food, heirloom crops, traditional home cooking techniques, family farming, frugality, self sufficiency, organic farming, and others. So, students' next technique is freezing. Freezing is also one of the most commonly used processes, both commercially and domestically, for preserving a very wide range of foods, including prepared foods that would not have required freezing in their unprepared state. For example, potato waffles are stored in the freezer, but potatoes themselves require only a cool, dark place to ensure many months storage. Cool, cold stores provide large volume, long term storage for strategic food stocks held in case of national emergency in many countries. Next process is boiling. Boiling liquid food items can kill any existing microbes. Milk and water are often boiled to kill any harmful microbes that may be present in them. So, students, next process is heating. Heating to temperatures which are sufficient to kill microorganisms inside the food is a method used with perpetual stews. Milk is also boiled before storing to kill many microorganisms. Sugaring, the earliest cultures have used sugar as a preservative, and it was commonplace to store fruit in honey. Similar to pickled food, sugar cane was brought to Europe through the trade routes. In northern climates, without sufficient sun to dry fruits, foods preserves are made by heating the fruit with sugar. Sugar tends to draw water from the microbes through plasmolysis. The process leaves the microbial cells dehydrated, thus killing them. In this way, the food will remain safe from microbial spoilage. Sugar is used to preserve fruits either in an antimicrobial syrup with fruits such as apples, pears, peaches, apricots, and plums, or in crystallized form where the preserved material is cooked in sugar to the point of crystallization and the resultant product is then stored dry. This method is used for the skins of citrus fruits, candied peel, angelica, and ginger. Also, sugaring can be used in the production of jam and jelly. So, students, next process is pickling. Pickling is a method of preserving food in an edible antimicrobial liquid. Pickling can be broadly classified into two categories: chemical pickling and fermentation pickling. In chemical pickling, the food is placed in an edible liquid that inhibits or kills bacteria and other microorganisms. Typical pickling agents include brine, high in salt, vinegar, alcohol, and vegetable oil. Many chemical pickling processes also involve heating or boiling so that the food being preserved becomes saturated with the pickling agent. Common chemically pickled foods include cucumbers, peppers, corned beef, herring, and eggs, as well as mixed vegetables such as pickle. In fermentation, pickling bacteria in the liquid produce organic acids as preservation agents, typically by a process that produces lactic acid through the presence of lactobacillus. Fermented pickles include sauerkraut, nukazu, kimchi, and surströmming. Now, next is lye. Sodium hydroxide lye makes food too alkaline for bacterial growth. Lye will saponify fats in the food, which will change its flavor and texture. Lutefisk uses lies in its preparation, as do some olive recipes. Modern recipes for century eggs also call for lye. Canning. Canning involves cooking food, sealing it in sterilized cans or jars, and boiling the containers to kill or weaken any remaining bacteria as a form of sterilization. It was invented by the French confectioner Nicolas Appert by 1806. This process was used by the French Navy to preserve meat, fruit, vegetables, and even milk. Although Appert had discovered a new way of preservation, it wasn't understood until 1864 when Louis Pasteur found the relationship between microorganisms, food spoilage, and illness. So, students, foods have varying degrees of natural protection against spoilage and may require that the final step occur in a pressure cooker. High acid fruits like strawberries require no preservatives to can and only a short boiling cycle, whereas marginal vegetables such as carrots require longer boiling and addition of other acidic elements. Low acid foods such as vegetables and meats require pressure canning. Food preserved by canning or bottling is at immediate risk of spoilage once the can or bottle has been opened. Lack of quality control in the canning process may allow increase ingress of water or microorganisms. Most such failures are rapidly detected as decomposition within the cane causes gas production and the cane will swell or burst. However, there have been examples of poor manufacture, under processing, and poor hygiene, allowing contamination of canned food by the obligate anaerobe Clostridium botulinum, which produces an acute toxin within the food, leading the severe illness or death. The, this organ produces no gas or obvious taste and remains undetected by taste or smell. Its toxin is denatured by cooking. However, cooked mushrooms handled poorly and then canned can support the growth of Staphylococcus aureus, which produces a toxin that is not destroyed by canning or subsequent reheating. So, students, next process is gelling. Food may be preserved by cooking in a material that solidifies to form a gel. Such materials include gelatin, agar, maize flour, and arrowroot flour. Some foods naturally form a protein gel when cooked, such as eggs and alvars and spunculate worms, which are a delicacy in Siman. In the fusion province of the People's Republic of China, Jellied eels are a delicacy in the east end of London, where they are eaten with mashed potatoes, potted meats in aspic, a gel made from gelatin and clarified meat broth, were a common way of serving meat offcuts in the UK until the 1950s. Many jugged meats are also jellied, a traditional British way of preserving meat, particularly shrimp, is by setting it in a pot and sealing it with a layer of fat. Also common as potted chicken, liver gelling is one of the steps in producing traditional paste. Next process is jugging. Meat can be preserved by jugging. Jugging is the process of stewing the meat, commonly game or fish, in a covered earth, earthenware jug or casserole. The animal to be jugged is usually cut into pieces, placed into a tightly sealed jug with brine or gravy, and stewed. Red wine and or the animal's own blood is sometimes added to the cooking liquid. Jugging was a popular method of preserving meat up until the middle of the 20th century. Burial of food can preserve it due to a variety of factors: lack of light, lack of oxygen, cool temperatures, pH level, or desiccants in the soil. Burial may be combined with other methods such as salting or fermentation. Most foods can be preserved in soil that is very dry and salty, thus, a desiccant such as sand or soil that is frozen. Next process is confit. Meat can be preserved by salting it, cooking it at or near 100 degrees centigrade in some kind of fat, such as lard or tallow, and then storing it immersed in the fat. These preparations were popular in Europe before refrigerators became ubiquitous. They are still popular in France where they are called confit. The preparation will keep longer if stored in a cold cellar or buried in a cold ground. Now we are going to study the process of fermentation. Some foods such as many cheeses, wines, and beers use specific microorganisms that combat spoilage from other less benign organisms. These microorganisms keep pathogens in check by creating an environment toxic for themselves and other microorganisms by producing acid or alcohol. Methods of fermentation include but are not limited to starter microorganisms, salt, hops, controlled, usually cool temperatures, and controlled, usually low levels of oxygen. These methods are used to create the specific controlled conditions that will support the desirable organisms that produce food fit for human consumption. Fermentation is the microbial conversion of starch and sugars into alcohol. Not only can fermentation produce alcohol, but it can also be a valuable preservation technique. Fermentation can also make foods more nutritious and palatable. For example, drinking water in the Middle Ages was dangerous because it often contained pathogens that could spread diseases. When the water is made into beer, the boiling during the brewing process kills any bacteria in the water that could make people say. Additionally, the water now has the nutrients from the barley and other ingredients, and the microorganisms can also produce vitamins as they ferment. Now, students, we are going to study the modern industrial techniques. Techniques of food preservation were developed in research laboratories for commercial applications. Pasteurization. Pasteurization is a process for preservation of liquid food. It was originally applied to combat the souring of young local wines. Today, the process is mainly applied to dairy products. In this method, milk is heated at about 70 degrees centigrade for 15 to 30 seconds to kill the bacteria present in it, and cooling it quickly to 10 degrees centigrade to prevent the remaining bacteria from growing. The milk is then stored in sterilized bottles or pouches in cold places. This method was invented by Louis Pasteur, a French chemist, in 1862. Now, the next process is vacuum packing. Vacuum packing stores food in a vacuum environment, usually in an airtight bag or bottle. The vacuum environment strips bacteria of oxygen needed for survival. Vacuum packing is commonly used for storing nuts to reduce loss of flavor from oxidization. A major drawback to vacuum packaging at the consumer level is that vacuum sealing can deform contents and rob certain foods, such as cheese, of its flavor. Freeze drying, artificial additives, preservative food additives can be antimicrobial, which inhibit the growth of bacteria or fungi, including mold, or antioxidants such as oxygen absorbers, which inhibit the oxidation of food constituents. Commonly, antimicrobial preservatives include calcium propionate, sodium nitrate, sulfates, and EDTA. Antioxidants include butylated hydroxyzole and butylated hydroxytoluene. Other preservatives include formaldehyde, usually in solution, glutaraldehyde, ethanol, and methyl chloroisothiazolinone. There is also another approach of impregnating packaging materials with antioxidants and antimicrobials, such as butylated hydroxyanisole, butylated hydroxytoluene, tocopherols, hinokitiol, lysozyme, niacin, natamycin, ketosan, and E. polylysine. So, next process of food preservation is irradiation. Irradiation of food is the exposure of food to ionizing radiation. Multiple types of ionizing radiation can be used, including beta particles, high energy electrons, and gamma rays emitted from radioactive sources such as cobalt 60 or cesium 137. Irradiation can kill bacteria, molds, and insect pests, reduce the ripening and spoiling of fruits, and at high doses induce sterility. The technology may be compared to pasteurization. It is sometimes called cold pasteurization as the product is not heated. Irradiation may allow lower quality or contaminated foods to be rendered marketable. Pulsed electric field electroporation is a method of for processing cells by means of brief pulses of a strong electric field. PEF holds potential as the type of lower temperature alternative pasteurization process for sterilizing food products. In PEF processing, a substance is placed between two electrodes, then the pulsed electric field is applied. The electric field enlarges the pores of the cell membranes, which kills the cells and releases their contents. PEF for food processing is a developing technology still being researched. There have been limited industrial applications of PEF processing for the pasteurization of fruit juices. To date, several PEF treated juices are available on the market in Europe. Furthermore, for several years, a juice pasteurization application in the US has used PEF for cell disintegration purposes, especially potato processors show great interest in PF technology as an efficient alternative for their preheaters. Potato applications are already operational in the US and Canada. There are also commercial PF potato applications in various countries in Europe as well as in Australia, India, and China. Modified atmosphere. Modifying atmosphere is a way to preserve food by operating on the atmosphere around it. Salad crops that are notoriously difficult to preserve are now being packed in sealed bags with an atmosphere modified to reduce the oxygen concentration and increase the carbon dioxide concentration. There is concern that although salad vegetables retain their appearance and texture in such conditions, this method of preservation may not retain nutrients, especially vitamins. There are two methods for preserving grains with carbon dioxide. One method is placing a block of dry ice in the bottom and filling the can with the grain. Another method is purging the container from the bottom by gaseous carbon dioxide from a cylinder or bulk supply vessels. Non-thermal plasma. This process subjects the surface of food to a flame or ionized gas molecules such as helium and or nitrogen. This causes microorganisms to die off on the surface. High pressure food preservation or pascalization refers to the use of a food preservation technique that makes use of high pressure pressed inside a vessel exerting 70,000 pounds per square inch, 480 MPa or more. Food can be processed so that it retains its fresh appearance, flavor, texture, and nutrients while disabling harmful microorganisms and slowing spoilage. By 2005, the process was being used for products ranging from orange juice to guacamole to deli meats and widely sold. Biopreservation. Biopreservation is the use of natural or controlled microbiota or antimicrobials as a way of preserving food and extending its shelf life. beneficial bacteria or the fermentation products produced by these bacteria are used in biopreservation to control spoilage and render pathogens inactive in food. It is benign ecological approach which is gaining increasing attention. Hurdle technology is a method of ensuring the pathogens in food products can be eliminated or controlled by combining more than one approach. These approaches can be thought of as hurdles the pathogen has to overcome it if it is to remain active in the food. The right combination of hurdles can ensure all pathogens are eliminated or rendered harmless in the final product. Hurdle technology has been defined by Lesnar as an intelligent combination of hurdles that secures the microbial safety and stability as well as the organoleptic and nutritional quality and the economic viability of food products. The organoleptic quality of the food refers to its sensory properties, that is its look, taste, smell and texture. Examples of hurdles in a food system or high temperature during processing, low temperature during storage, increasing the acidity, lowering the water activity or redox potential, and the presence of preservatives or biopreservatives according to the type of pathogens and how risky they are. The intensity of the hurdles can be adjusted individually to meet consumer preferences in an economical way without sacrificing the safety of the products. So, students, thank you very much for listening with patience.